We're looking at the prompt from 2019 question 4 of the AP Statistics for Response test. And it starts off by saying tumbleweed, but I'm not going to read the entire prompt. What I want to do is I want to focus on that last question down there where it says, do the data provide convincing statistical evidence? And that's important because it's telling me that I'm probably going to be doing a significance test. Now, I don't know if it's for means, for proportions, one sample, two sample, chi-squared. I don't know which one I'm dealing with yet. But I now know how to read the rest of this prompt. And I'm also going to pay attention to the fact that it's giving me an increase. Now that's probably going to help me with my alternative hypotheses. It's telling me increase. So I'm thinking greater than for the alternative. And I can keep going through and read the entire prompt, and I see that I have 19.7% of 61 and 38.5% of 52. So I have two proportions given to me, so I'm thinking I'm dealing with a two sample z-test for P1 minus P2. That's where my brain's going. And I can see that I'm dealing with it being randomly selected. So now I have random selection being there. I see two population, proportions, and statistical evidence. So now I can have an idea of what I'm going to do. And you can see down here I have underlined a few things as well. The 2014, the 2017, and the context. Proportion of all cochea plants that are resistant to glyphosate. So now I have how to write everything down when I'm dealing with the prompt. So I'm going to choose first. What test am I going to perform? And then I'm going to actually write everything down that's in the state step. So first I want to say, hey, I want to perform a two proportion z-test or two sample z-test for P sub 2017 minus P sub 2014. So rather than saying P sub 1 minus P sub 2, I'm going to use the years there so I can keep an idea of the order. I have to state the significance level. It was told to me in the prompt at alpha equals 0.05. Then I'm going to state my hypotheses. And so I have my null that the difference between the two proportions is equal to 0. That's saying there is no difference. And then my alternative, it said increase in the prompt. So I'm going to say the difference between the two proportions is greater than. If there was an increase from 2014 to 2017, then I'm going to have a larger number in 2017. So there are my null and alternative. Now that's one way of doing it, and you can also write it this way for full credit as well, saying that they're equal to each other for the null, and saying that the proportion of cochea plants that are resistant to glyphosate in 2017 is greater than that than in 2014. And notice I am using the subscripts there, so I better define them. So I have to define my variables, and not just by saying proportion in 2017, proportion in 2014. I have to use the context that was underlined and italicized in the previous slides. So I can tell you right here at P sub 2017 is the two proportion of the cochea plants in 2017 that were resistant to glyphosate, and same thing when it comes to 2014. So there's my state step. I'm choosing what I'm dealing with, and I go through. Now, you can see I have everything highlighted here, and these are kind of the four main criteria that they're looking at when they're dealing with this choose. You want to state the test you're dealing with, you want to state the significance level, the hypotheses, and define your variables. Really important. And make sure you're using the context, and that context was given to us in that last question of the prompt. So the next part is going to be dealing with our check. We're going to look at that, what we call the plan step. We're going to check all of our conditions is what we're looking at. And so first off, we were told that it was random. We were told both of them are randomly selected. I have a sample size of 52 from 2017, and I have a sample size of 61 from 2014, both randomly selected. Now, don't just rush past that random selection thing. That's really, really important. And you can see down here, I have a picture of the posters from the classroom. Is the reason why is because it allows us to deal with scope of inference. Now, you have the diagram right here that talks about random assignment versus random selection. But over on the far side, you can see that random selection allows us to generalize the results back to the population. So we're dealing with a significance test that will allow us to infer on the population. So this random step is so simple to do, we kind of forget the importance of it when it deals with the actual conclusions that we can draw. So now let's go next into normality. Now this one's going to take some work. And I'm going to pull up what we had from the prompt. The prompt didn't tell us how many successes that we had from 2017 to 2016. It told us a sample proportion. It told us 38.5% of the 52 plants. So I need to multiply to get those counts. And the same thing in 2014. It told me that I had 19.7 of the 61 plants. So I had to multiply to get those counts. So this one was a little tricky. There were no counts given you for those. They gave you the p hat and the sample size for each one, and you had to multiply them to get those. So I'm going to use these when checking the normal condition. So I'm going to do that. Remember, when we're dealing with a significance test with two proportions, we need to do a combined proportion between them. We're going to take the number of successes, since we're saying that our hypotheses that are null, they are equal to each other. We're going to get a better proportion to use. We are going to combine all the successes from 2017. We're going to combine all the successes from 2014 and divide by the total sample size from both years. That's going to give us a better idea, because if we're saying that there's no difference, then we should be able to combine them. And we look at it, so I'm going to have the 2017, there was about 20.02. I am going to use the decimal here because I'm going to combine them, and maybe I'm going to round at the end out of the 52. And then I have when it comes to 2014, the 12.02 out of the 61. I combine them, I get 32.04 out of 113, 0.2835. We're good to go. That's my p hat sub c. I'm going to use that when checking my normal conditions. So now we had to do all this work right here with trying to figure out how many successes and failures in 2017 and 2014 to get that p hat sub c over there. So now I'm going to look at the number of successes and failures in both the samples we dealt with. And so when I have my p hat sub c of about 0.2835, I'm going to look at the expected counts in 2017. And if I do that, I'm going to multiply that 0.2835 and its complement by the sample size of 52. And I'd get 14.7 and 37.3 successes and failures. And I do the same thing when it comes to 2014 expected counts. Take the 0.2835, the combined proportion, multiply by 61, and take its complement, the failures, and multiply by 61, 17.3 and 43.7. Good news is those are both larger than 10. I have a large enough expected number of successes and failures to proceed with normal approximations. So there's my check step. So be very careful when it comes to the normality part of that check step, but I still need to check for independence. And so I'm looking at independence. The thing that's different when you have two samples is they need to be independent both between and within. And so the between is the new part. I can't take and analyze from two populations that are kind of in a way are going to affect each other. They have to be separate populations. And so we have to make a statement. It is safe to assume that the number of cochea plants that are affected by glyphosate in 2014 and 2017, that those samples are independent of each other. But within is the same as it was before. It's the 10% condition, since we're doing with random selection. And so when we're looking at this, I have to do it for both of them. I have to do it for 2017 and 2014. And so it's safe to assume that there are more than 610 cochea plants in 2014 and more than 520 cochea plants in 2017. So the within is the idea of sampling without replacement and the 10% condition. But this part right here is those two populations, those two samples need to be independent of each other. I need to state that as well. So I got the between, I got the within. So I dealt with random, I dealt with normality, I dealt with independence. You know what? Time for some calculation. So here we go. Let's take a look. We have our formula, and these are the two different ways. The one right next to me, the one right here is the way it looks on your formula sheet. The one that's further away, that's kind of the way we're going to write it. It's just one has the p hat sub c and the one minus p hat sub c distributed to the numerators of the fractions in the square root. But it's really important to remember that this is actually the formula on the front page of your formula sheet when it comes to your test statistic. And I have it highlighted here in color code for both it's really statistic minus parameter over standard error of the statistic. Both of them have that structure that we've been dealing with since way back to the beginning of z-scores. And so it's statistic minus parameter divided by the standard error of statistic, and we have those. So now let's just go ahead and plug everything in. We have our p hat sub 1, which was really the p hat sub 2017. We have our p hat sub 2, which is really the 2014 proportion. And the parameter was our null. We said there's no difference between them. So that's where you see the equals 0 there. And don't forget, when I'm dealing with the standard error of the statistic, I have down there the p hat sub c and the 1 minus p hat sub c over my two sample sizes. So that's the structure for your z-score that you need to write down. And if I type that all in my calculator, I'm going to get about 2.21. And so now when I'm looking at this, I have all my information I need to do to sketch the curve. And so if I look at the curve, I can see where I'm at. And on my curve down here, you can see that I'm dealing with my z-scores. I have down here the 0, the 1, the 2, the 3, and so on. You can see what's going on. But it's also the same idea when we're looking at the p hats. Is when I'm going through this, right here is saying that I have a difference of 0 between them. Right here is going to be my 0.385 minus my 0.197. That's going to be the location when you're looking at your p hats. The p hats of 2017 minus the p hats of 2014. That's where the location falls from what we witnessed. So I have my z-score. Now I need to look at what's the p-value that's associated with that z-score. And the p-value there would be about 1.36%. So 0.0136. So I have all my information is if I want the probability of a z-score being greater than 2.21 in this scenario, it's going to be about 0.0136. There's your calculate. Time to conclude. And so my conclusion, I'm going to pull up what we have on the posters in the room is how does our p-value compare to our alpha level and what's our decision and the context that we're dealing with. And so when I'm looking at this one, I could see right away that I have, since the p-value of 0.0136 is, well, that's less than my alpha level of 0.05. You know what that means? That means we are going to reject the null hypothesis. So what does it mean in context to reject the null hypothesis? Well, it means that we can say that we have sufficient evidence to conclude that the proportion of cachea plants resistant to glyphosate in 2017 is greater than that of cachea plants resistant to glyphosate in 2014. So you can see it color-coded here is my p-value associated to my alpha level, what's my decision, and the context of the conclusion. If we are rejecting the null and concluding the alternative, was that 2017 proportion of cachea plants resistant to glyphosate was greater than that than in 2014. Really hard to say. So there I am. I'm done. But of course, you know what that means. That was a lot of work. Let's look at the calculator to kind of see how can I get my answer as well. And so we're going to look at the NumWorks calculator over there to the side. And so if I use the arrows on the side, I'd be able to choose and go down to the inference area. And by going to inference, it's going to give me an option. Okay, what inference procedures do I want to deal with? Do I want to deal with tests or intervals? Well, tests. We did a 2 proportion z-test for p1 minus p2. And look right there, 2 proportion z-test. So if I select that, here's what I have next is my null and my alternative. Well, null, it's set in stone. I can't change it. P1 minus P2 equals 0. Now my alternative was not less than or not equal to, it was greater than. So I'm going to go to the drop-down menu and select greater than. And then I'm going to hit next. And so I have my null and my alternative. So now I need define my parameters, successes from the first sample and my sample size from the first sample. And so if I look at that, I got to pull these back up on what I had written down right here. I had about 20.02 right there, and I have about 12.02. So I'm going to type in 20 and 52, and then I'm going to go to the second sample and say I had 12 successes out of a sample size of 61, and I have an alpha level that told me of 0.05. So I type that in. And then I go into the next button. And if I look at that, let's see what's next. That's all the values I needed. And I have highlighted there, it says pool proportion. That's your combined proportion. So there's your p hats of 1, your p hats of 2, your combined proportion. You can see about 2.2095, so about 2.21, just like we said. And I can scroll down as well and look at the p-value, about 0.01356. And so if I look at that, there we are. But it's not done there. If I hit the next button again, it will pull up a picture for me, which is really, really interesting because that picture, and I'll zoom in on this one, shows you right here, the orange is the p-value, and that dashed is your alpha level, your significance level. And if I look at the graph, I could see that my shaded region, that p-value is inside that significance level. It's telling me it's in the significance level. What I found is statistically significant. I can reject the null hypothesis and conclude the alternative in context. And so there you are with the numbers calculator. That is the question from 2019, number 4, dealing with a two proportion z-test of P1 minus P2. Thanks for watching.